Hey everyone, welcome to lesson 1.7, absolute value equations. We are going to, as it sounds like, be solving equations with absolute values and recognizing when that becomes two solutions, no solutions, or an extraneous solution, which sounds a little funky, but that's why we're going to talk about it. So first things first, the absolute value of x is just simply the distance between x and 0. So how far away is this number from 0? And a lot of people consider it making everything positive because absolute values always equal positive numbers because only distance matters, meaning it doesn't matter if you go towards the positive or negative direction, it's still the same amount. Okay? For example, if you took the absolute value of x and set it equal to 3, this is really just trying to say that x is 3 units away from 0. Well, there's two ways that you can do that. If you start at 0, you can either go 1, 2, 3, there's one of your solutions, or you can go 1, 2, 3, there's one of your solutions. So really, this gives you x equals 3 and x equals negative 3 as your answers, since it does not matter which direction you go in. And therefore, every absolute value equation is going to start off by giving us two solutions, unless it has none, and I'll talk about that on the back side of notes. All right, moving on. So as we're solving absolute value equations, the first thing you want to do is get the absolute value by itself. So isolate it. This means getting rid of everything outside the absolute values. If it's not 11, it's not just two random lines, that is an absolute value. Okay, so you only want the absolute value left on one side. Once you have that, then you're going to set it up as two equations, one plus and one minus. Kind of like how the last one was 3 and negative 3, you'll do that before you continue solving. This is the only way to get rid of the absolute value bars, is by setting it up as two equations. Then lastly, solve for x in both equations. Okay? So isolate it, set it up as two equations, solve for x. And that's how you're going to get your two solutions. Once again, you have two solutions because absolute values can take away a negative. So we don't know if the negative was originally there or not. Okay, and that looks really small, so let's see if I can, there we go, make that a little bigger. The absolute value is the only thing on the left side, so it's already isolated. So what we're going to do is jump straight into splitting it up into two equations. X minus 3 over 4 equals 6. X minus 3 over 4 equals negative 6. And we're just going to solve both of these equations. Okay? Whenever you're dividing or there's a fraction, that's just division, so you're going to multiply to get rid of that fraction. Okay? And a heads up that these are actually going to solve in the exact same way. So I'm going to go ahead and do my step on both sides so I don't have to think through it twice. So my 4's cancel out and I have x minus 3 equals 24. And then over here, my 4's cancel out, but I have x minus 3 equals negative 24. And these equations are always going to be what I call parallel, meaning that they're going to solve in the exact same way. Okay, so then I have to get rid of the minus 3, I'm going to add 3. X equals 27. And over here, negative 24 plus 3 is negative 21. Okay, go ahead and pause the video if you need to write that one down. Let's make this a little bigger again. Okay. So the absolute value is not by itself, so I have to do that first. I'm going to start by minusing the 5. 13 minus 5 is 8. So 4 absolute value of x equals 8. Then I'm going to divide by the 4 because it is also outside. Okay, so we get the absolute value of x equals 2. Notice how x is the only thing left inside that absolute value? That means when you set it up as two equations, it's just going to be simply x equals 2 and x equals negative 2. And you are done. There's no solving left because x is the only thing left. All right? Okay, so this one's got 3 pieces to it that we have to worry about. Now, when I work on this, I'm going to move the 4 and the 2 because those are outside. The 3 has to wait a second because it is trapped inside the absolute value bars. Okay, I'm going to start with the 4 because remember we're doing PIMDAS backwards. 7 minus 4 is 3. Divide by 2. Don't freak out. 3 divided by 2. We're just going to leave it as 3 divided by 2. Okay? But before I move on, I'm going to go ahead and cross this out and change it to, I can remember how to do math correctly, that helps. 6 over 2. 3 is 6 halves. 6 divided by 2 is 3. I'm changing it that way so when I get to it here in a second, I already have halves so that I can add them together. Okay? That absolute value is by itself now, so I have simply x minus, 6 halves equals 3 halves, and x minus 6 halves equals negative 3 halves. And all I have to do for my last step is add that 6 halves to both sides. The whole reason why I changed that is because 3 halves plus 6 halves is 9 halves. And then on the right side, adding 6 halves, negative 3 halves plus 6 halves, negative 3 plus 6 is positive 3 halves. And I have my two answers, 9 halves and 3 halves. All right, last one on this side, I believe. Now I gave this one a whopper. I made it 4 steps, okay? To get rid of the minus 4, I'm going to plus 4. Sorry, I wrote that 4 weird. 3 absolute value of 2x plus 8 equals 14 plus 4, 18. Then to get rid of our 3, we're going to divide. Absolute value of 2x plus 8 equals 18 divided by 3, 6. The absolute value is now by itself. So to get rid of those 2 bars, we're going to say 2x plus 8 equals 6. 2x plus 8 equals negative 6. And then I'm going to solve these both at the exact same time, just like I did before. I got to minus my 8. 6 minus 8 is negative 2. And negative 6 minus 8 is negative 14. And then we are simply dividing our answers by 2. Negative 2 divided by 2, negative 1. 14, negative 14 divided by 2, okay, sorry, negative 7. And there you have it. So even if an equation looks really long and scary at the beginning, remember it's just taking it one step at a time. Okay, I'm going to keep going for a few more, and then I'm going to leave a couple of examples for class. Okay, so there are tricky situations that come up with absolute values. Some of them are going to have no solutions. They can't be solved because the absolute value can't equal a negative number. So no solutions occur whenever the absolute value equals a negative number. Okay, if you want to write an example, because there's a negative on the right side of that equal sign, it can't be solved. Okay. And then there's something called extraneous solutions. You've probably heard of them before, but maybe haven't done a whole lot with them. They are solutions or values that don't work when you plug them back in. So with absolute values and things like x squared, as you're solving, some of the steps you do end up creating extra values that don't end up working when you plug them back in. Okay, and this for us is mainly going to happen when there are variables on the outside of the absolute value. Because there are some outside, that makes the signs a little bit tricky. Okay, I'm going to do the first two, and then I'm going to leave the last four for in class. Okay, this one right here, absolute value of 4x plus 7 equals negative 3. This is a negative number. Sad face, we can't solve that, okay? Actually, for some of us, you might be putting a happy face, because that means that you don't have to solve it. So when absolute values equal negative numbers, you don't have to show any work because there's no solution. Be careful though, because just because you see a negative on that side doesn't mean it's still going to be there after you isolate it. Okay, so if you notice on this one, it is equal to negative 3, but there's this negative 10 hanging around outside, and once I move it over like it's supposed to be, negative 3 plus 10 is positive 7. So this is okay because we need to wait until the absolute value is isolated. And then I'll go ahead and finish solving this one. The absolute value is isolated, meaning that my two equations will be 4x minus 13 can equal 7, or 4x minus 13 can equal negative 7. I'm going to add 13 to both sides on both equations. 7 plus 13 is 20. And negative 7 plus 13 is 6. Then all I have to do is divide by 4. 20 divided by 4 is 5. 6 divided by 4 is a decimal. Instead of writing it as 6 over 4, I'm going to kind of remind you how to reduce fractions. We can divide both of those numbers by 2, leaving us with 3 halves. Alright, that's where I'm going to pause for today. I will do a few examples at the beginning of class on Friday.